In this video, we're going to be solving functions involving multiple angles, specifically trigonometric functions of multiple angles, in the forms the cosine of KU and the tangent of KU. So to solve these equations, when they're in this form, you first solve the equation for KU and then divide your result by K. So let's go ahead with our first example. For letter A here, we have 2 times the cosine of 3t minus 1. So we want to isolate the cosine of 3t. So to do that, we're going to begin by adding 1 to each side. And then dividing both sides by 2, giving us the cosine of 3t equals 1/2. So we now have isolated our cosine of 3t, and we're ready to use u substitution. So we're going to let u equal the cosine of 3t, or rather, not the cosine of 3t, but specifically 3t, which is a little bit different than what we've been doing recently. So from here, if we now write this, we have the cosine of u equals 1/2. And if we look at our unit circle, we see that the x value is 1/2 at here, pi over 3, and then again here at 5 pi over 3. And so we're going to use those answers. And so we have that u equals the pi over 3 and that u equals 5 pi over 3. Now because we weren't given an interval, then what we really have is that u equals pi over 3 plus our 2n pi, because we're dealing with cosine, and that u equals 5 pi over 3 plus our 2n pi. So now that the u is by itself and it's solved for, we're ready to replace our u with the 3t, right, with that 3t. So we'll rewrite this as 3t equals pi over 3 plus 2n pi. Let's give ourselves a little bit more room. We'll move this down a little bit. And right here we'll have that 3t equals 5 pi over 3 plus 2n pi. So we just replaced our u with the 3t. And then following our second step, we're going to just divide everything by that 3 to isolate the t. So that's going to give us that t equals pi over 9 plus 2n pi over 3. And that t is going to give us 5 pi over 9 plus 2n pi over 3. And those are going to be our two solutions that we get. Let's try another one. Here we have 3 times the tangent of x over 2 plus 3 equals 0. So we want to isolate our tangent of x over 2. So we're going to do that by first. And so we're going to subtract 3 from both sides first. Then that's going to give us 3 times the tangent of x over 2 equals -3. Then we're going to divide both sides by -3, which is going to give us the tangent of x over 2 equals -1. And we now have our x over 2 isolated. So we're going to use our u substitution, letting u equal the x over 2, giving us the tangent of u equals -1. And so now we're going to bring back our unit circle for a moment. And remember that the tangent means it's the y divided by the x. So that would tell us that if we want it to be a -1, that the x and the y have to be the same value, except one needs to be positive and the other needs to be negative. And so if we look at our unit circle, the only place that we see that happen occurs here when we have radical 2 over 2 and radical 2 over 2. But A negative divided by a negative is a positive, and a positive divided by a positive is a positive. And so we only have these two solution sets for us. And also, tangent doesn't have a period of 2 pi. Tangent only has a period of pi, which means no answers in our bottom two quadrants would work. So the only solution that would work would be 3 pi over 4. And because we weren't given an interval, our answer is going to be that u equals 3 pi over 4 plus n pi. So not just pi, but n pi, because we don't know how many times we're going to be going through. So now we want to replace our u with our x over 2. And so that's going to give us x over 2 equals 3 pi over 4 plus n pi. And we're going to solve for the x here. We're trying to solve for the x here. And so in order to get rid of the x there, we are going to multiply both sides by 2, which is going to give us x equals, now we're going to have to distribute this 2, right? So that is going to give us a 6 over 4, which reduces to a 3 pi over 2, plus we're going to have a 2n pi there. So now we have our x value, and that will be our final answer.